We pull back further. Stars begin to gather into a glowing band. The Milky Way, a spiral galaxy about 100,000 light-years across, containing hundreds of billions of stars. From within it, the Milky Way feels infinite. Its dust lanes stretch endlessly across the night sky. But from the outside, it's just one island of light in a dark cosmic ocean. There are galaxies larger than ours, far larger, elliptical giants with halos stretching millions of light-years, containing trillions of stars. And yet, even these galactic titans are not the largest things the universe has built, because galaxies do not live alone. As we continue outward, we begin to see structure. Galaxies gather into groups, bound together by gravity. Our Milky Way belongs to the local group, a small family dominated by the Milky Way and Andromeda. But beyond groups come clusters, vast cities of galaxies. Some clusters contain thousands of galaxies, immersed in clouds of superheated gas. Their combined gravity so intense it bends light itself. These clusters can span millions of light-years. At this scale, space is no longer empty. It's dynamic, alive with motion. But even clusters are not alone. They too gather. Clusters connect into even larger formations called superclusters. These are not tightly bound objects. They are loose, sprawling regions, where galaxy clusters appear more frequently than average. Our home lies within the Laniakea supercluster, a structure over 500 million light-years across. At this scale, gravity is no longer pulling everything together. Instead, the expansion of the universe begins to compete. Superclusters are temporary, cosmic patterns frozen in time. And yet, even they are just hints of something larger. Because when astronomers mapped the universe in its entirety, they noticed something astonishing. Zoom out far enough, and the universe reveals its true architecture. Galaxies are not scattered randomly. They trace vast filaments of matter, thread-like structures stretching across unimaginable distances. Between them lie enormous voids, regions nearly empty of galaxies. Together, these filaments and voids form the cosmic web. It looks almost biological, like neurons or frost spreading across glass. This web is shaped by dark matter, an invisible substance that outweighs normal matter 5-to-1. Dark matter doesn't shine. It doesn't glow, but its gravity sculpted the universe. Galaxies formed along these invisible threads, like dew collecting on spider silk. And along these filaments lie the largest structures ever discovered. Among the most mind-bending discoveries in cosmology are the Great Walls. These are colossal chains of galaxies, stitched together across hundreds of millions, sometimes billions of light-years. One of the most famous is the Sloan Great Wall, over 1.3 billion light-years long. But even that is not the largest. That title belongs, at least for now, to a structure so immense it challenges our understanding of cosmic order. Far beyond our local universe, astronomers discovered a structure unlike anything seen before. The Hercules, Corona Borealis Great Wall. It stretches across an estimated 10 billion light-years. To put that into perspective, the observable universe itself is about 93 billion light-years across. This single structure spans more than 1/10 of everything we can see. It is not a solid wall, not an object you could touch. It is a statistical pattern, a region where galaxies and galaxy clusters appear more frequently than elsewhere. And yet, its sheer scale raises deep questions. At this size, the universe was supposed to be smooth, uniform. Large enough structures weren't supposed to exist. Subscribe for more quiet travels through the universe.